Welcome to the project, everyone. Today we have a really fun one. If you notice, I'm just getting over being sick, so I probably sound a little funny, but my excitement for this can't hold back any longer, and I basically feel good other than I sound a little funny. So hopefully you can bear with it. But today, we have this. It's the Genmitsu 3020 Pro. If you've been following the channel for a little bit, you've probably recognized that I'm all about increasing the capabilities of the shop and increasing what we can do and what fun projects we can shoot for. And so I think this will really upgrade what we want to do. It's a little bit different than the content we've made so far because this is brand new, but I think it'll fit right in, and I'm really excited to tear into this. I haven't done anything like this before. I've been kind of holding off to get back into 3D printing, but like right now there's a couple projects that I could really use a CNC. So in the end, I would like to mill out some small aluminum parts. I'd be fine if it's just aluminum engraving, but ultimately it's going to be awesome to be able to cut out wood, engrave wood, cut out plastic, engrave plastic. That's all stuff that like could be really useful for us here in the shop. So I'm excited to dig into this. I'm excited to see how this goes. I'm a little worried. Genmitsu has the 3018. And I opted for the 3020 because of a few different things, and I can probably talk about that once we get into it. But let's open it up finally and see what's inside. So I will say I ordered this from Amazon. It looks like they shipped it to the US, and then they shipped it to Amazon, and then Amazon shipped it to me. So there's quite a few shipping labels on there. But I will have affiliate links if you want to make sure you get the exact same thing as me. Some stickers and a manual. Well, yeah, I guess let's just start. Chip brush, some wire loom, USB cable, zip ties. Is this the power supply? No, that's the control board. We got a loose screw. Oh, it looks like it came from here. So here's the spindle, or the motor. Man, all sorts of stuff in here. Okay, I will say that was pretty adequately packaged. As you see, some of this stuff is pre-assembled. We have like this whole bottom tray set up and then this whole upper spindle set up. The clamps for the spindle, one of the bolts came out, but I did find the washer, or like the threaded square nut on the other side, which means I can put that back. So, without reading any of the instructions, just looking at all this stuff, it looks like we need to mount the control board, wire up the power supply, put the spindle in there, put in all the limit switches and the e-stop and everything else, wire up everything. Make sure everything's all nice and plumb, and then we should be pretty good. Give you some zip ties, some wire loom, but let's read the instructions and see what they suggest we do. So I'm gonna do some reading and then probably just start time-lapsing, putting this all together, and then we can start talking about it a little bit. So I decided to start doing a little bit of checking before I even started assembling it, like how square everything is. It's a little off, like this bottom plate. It's not exactly square. Granted, I don't have the best tool to check it. I've just got my freaking framing square, or speed square. So I might try to loosen this up and get that straightened out. But one of the other things I was really concerned about is right here. So this is the stepper motor, if you didn't know. This is what drives it. We've got a fancy little knob right here, and this whole thing's upside down. So we got the plate here. This is this is how the stepper motor connects to the plate. So any play in this system is going to translate to play in the plate that we mount everything to. So if we get chatter and whatnot, it's going to be through one of these joints. And I did see someone online say that it was laughable how weak the springs were to get rid of the backlash, and I see what they're saying right now. So I don't know exactly how all this works, but I can say that there's this bronze piece right here and a spring right there that is really weak. From what I gather, this is the piece that takes the backlash out, and I don't have to hardly push on that at all. I mean, it may not seem like much, but that is enough to cause chatter. So I almost wonder if I should just take this apart and see if I can get a way stronger spring right there. And for all the other ones, even before I start putting it together. Because, I mean, it's apart right now, so might as well take advantage of it. And it's only going to make us better in the long run. So let's start digging into it. Alright, here we go. Here's the spring that is too weak. And this spring, all it does is it fits between these two. Nothing too fancy here. This side's threaded, that side's threaded, and then there's a spring between them. This side's mounted to the table, this just pushes against it, so that way the backlash is gone. So if we can find a more powerful this that still fits in the hole, then that would be great. There isn't necessarily a ton of room, but we'll see. Here's something of interest. This vertical axis, there's a lot less play in it. It almost seems like a lot of the play is coming from the stepper motor itself, because like the only thing keeping it from going up and down, I don't think down here keeps it, but I could be wrong, but it's mainly up here in the stepper motor, and so there's like a little bit of play there. But that means like maybe this spring is fine, but now I need to check this axis, so we got to get all this greasy stuff out of here. So yeah, there's a lot less play, but that spring still can be upgraded in there. And it looks like they're using all the same design. So if I get the same spring, then I should be able to replace them all, and then we can go on from there. Alright, well, as you can probably tell from my voice, it has been a little bit. I'm feeling a bit better. I mean, when I last filmed, I was like kind of on the tail end and I was feeling fine. My voice just sounded weird. But that has also given us some time to order some springs. So, like I mentioned, the springs right here to take this backlash out were really weak. So let's actually talk about this a little bit. So I have learned some things since trying to do research for this and trying to figure out what springs to order. So let me get set up and then we can start talking about springs. Oh, also, I ordered a microphone. Like, it's got to be like 8 months ago. I mean, like almost a year ago. It's crazy. I thought it would never come, but then this last week they finally got stock, and I finally was able to get my my back order to come in. So we finally have a new microphone on here. I think you'd notice I typically use like the little lapel microphone, but you know, I'm at least gonna do a couple clips with this microphone to see how it works out, and you guys will have to let me know how you think. But okay, so let's get reset up, and then we'll start talking about it. Yeah. Okay, so how do you go about finding a new spring? Well, there's a couple main factors about a spring. You obviously have the outside diameter, you have the inside diameter. The wire thickness is going to also determine those different factors. And then you have your free length. So like this, that's the free length. You have your like max compressed length, which is that, or like the hard length, I forget what that's called. And then you have the spring rate, and I'm pretty sure I'm doing this right, but this is how I found my spring rate. So I used my garage scale in here, and what we want to do is we just turn it on, and as you see, I have a ruler here. So we're just going to come in, put our spring on there, tear it, and then what we're gonna do is look at it, and it's like 1 7/8 high. So what I'm gonna do is actually push down 1 inch, and then we're gonna look at the reading on the scale. So let's see if I can do this without having the spring go all over the place. Ugh. And it's kind of hard, it's not an exact science, but you see it's like 12 ounces or so. So the original spring is 12 ounces. And if we do some calculations, because it's 16 ounces in a pound, right? So yeah, so if we do 16 divided by 12, 12 divided by 16 ounces, we get 7.75. So it's the spring rate of this spring is 3/4 of a pound.
And as I started looking for springs, I did all my measurements and I found these two. And what I found is that this guy, so I did two different spring rates and both of these should fit. This guy is, so again, we're at 3/4, so this is 1.15 pounds per inch, and then this is 5 pounds per inch. So this is like, I mean, should be more than 5 times the pressure on that, and then this one should be, you know, maybe, I don't feel like doing math right now. It should be a bit more than what we currently have. The issue is with this is that I didn't take into account the free length. So I was like, oh yeah, this spring is fine, you know, like it'll be in there and, sorry, this spring is fine. It'll be in there and it'll get compressed a little bit and it's a higher spring rate. So that should put more pressure against the threads in there and keep it tighter, right? Well, I'm wrong because spring rate, there's two things that go into it. The spring rate and then how much it's actually compressed. So what happened is on these guys, I measured the distance. I measured like how far it's compressed. And this spring right here, even though it's 3/4 pound for the spring rate and that one's a higher spring rate, when it's compressed, this gives about 1 pound of pressure against the threads. And when this guy, because he's shorter, he doesn't get compressed nearly as far. He puts like about the same. I think it's about like 1 pound or so. And so there is no benefit to moving to this spring from the original spring, which means we have this guy, which sure enough, when it's compressed in there to the right length, it's about 1 inch. So this guy gives about 5 pounds of pressure against the threads in there, which, I mean, that I'm on the fence. 5 times the pressure, it makes me feel a little concerned. Not that it'll break or anything, but my concern here is that it's the pressure on these threads is going to wear out these pieces faster, and it's going to make it too hard for the stepper motors to move. But I can always cut these things down so that way they don't exert as much pressure in there. So I'm going to just run with it. I didn't choose the springs quite correctly, and 5 times is quite a bit more, but hopefully stepper motors can overdrive it. So we're just going to put them in there and run it and see how it is. If I get the bad feelies with that guy, then we'll take it apart and cut it down. But for now, I'm just going to run it. I will put at least that spring in the description. So if you guys want to follow me, 5 times the pressure. I don't know if it'll be good, but you guys can at least order those springs. And just to show you guys, this guy, oh geez. Yeah, he compresses quite a bit. So a quick note is, yes, I did pick up this little dial indicator from Harbor Freight. I heard they're decent. Been a bit of an interesting learning curve so far, but we'll see how it goes. I might be able to measure some things with this. Okay, so also one thing that I will note is that I feel like a lot of these issues could be solved with higher quality of manufacturing. The threads in this piece right here that these screws go into are like not the right size. So these screws like barely catch on the threads and barely hold that in. And then again, the threads on these two brass pieces, or whatever they are, they're so loose that that's why this spring is such a big issue. So if I was a better machinist, you know, if I had the tools, then I would probably re-machine this and then bore these out and put those like actual threads and actual screws and like the right screws into there. But whatever, we're just going to run it like we have it and see how it goes. I don't know if this does help, but I like to think that the way that we tighten things on this is they can actually matter. So right now, mounting to this bottom plate is going to be pretty important. And then down in here, where we have this motor, if I loosen these a little bit, then this whole motor can float a bit. So what I'm going to do, so I'm going to keep these a little bit loose. So again, I mean, it's not much, but that can float around. And then I'm going to move this all the way over here, so that way this is dictating the height of the threads, and then I'll tighten the motor down and we'll go from there. So now that we have our y-axis, z-axis, I need to memorize the axes. So now that we have this guy set up, you can see there still is some play in here, and I might actually be able to get a reading of how much play I have in mine. Okay, hopefully you guys can see this. So like, let me get it right on 0. We're on 0 there, and if I push against the spring, you can see, yeah, back to 0 if I'm not leaning on the bench. I think that's like almost 9 thousandths, 8.5 thousandths. And if I push, and then I can push into the motor, we can get a lot of play into there. So the spring is taking out the backlash in the connection there, and it's honestly just about as strong as when we start pushing stuff inside the motor. So that's obviously not good to push stuff inside the motor, so to have this backlash about as strong as that is awesome. So I actually kind of like this. We'll see how well it works. Maybe I've screwed it up, but at least we can see that. Do you guys notice anything different about these two springs? Here's one of the ones in the other axes, and then this is for the height, which is like what, the Y, or is that the Z? The Z axis. This one, that's a quite beefier spring in there. So they obviously had some vibration issues in the Z axis up and down, and so they put in a stronger spring up there. I don't know why they didn't do this for all the other axes, but whatever. I think our spring is a little bit stronger, so we're still going to put it in. All right, well, now that we've spent hours and hours and a bit of money, we finally have all of the springs installed. And again, it was really interesting. Weaker springs for this axis and this axis, but the up and down had a stronger spring in it, but we got them all in there. If you do this yourself, one thing to watch out for is that like the two brass pieces, they can flip like 180, and just try both of them and see which one's tighter if there is one, because I actually put together my Z, my up and down axis, and it was a bit looser than when I originally had it, so I had to take it apart and put it back together. But Now we are ready. It is getting kind of late tonight, but I at least want to try to get the gantry onto, what do they call it? The base assembly. So now let's actually get to assembling it. Alright, it's a brand new day. The next thing on the list is limit switches. So let's put these limit switches on here. We got 3 of them. And then I think it's E-stop. So let's get to it. Okay, so I will say this limit switch here on this axis, they say to use the 10 millimeter long ones, and yeah, they're gonna bottom out on this plate. They're gonna screw through and hit the plate. So we're gonna use these really short ones, because I do not think, because again, like if I put this through and I line it up, it's gonna hit the freaking back piece. So we're gonna try these shorter ones, because I don't see these shorter ones being used anywhere else, and that should get us going. Up next is the kill switch. There we have it, the control board, which still has the protective plastic on this top piece and the bottom piece and all the pieces. So, a while ago, for another project, I got these BL89 or 8892-NDs, the part number, and they're just little cable ties. So you've got adhesive on one side and then little loops to do cable ties on the other. So I'm going to use these to kind of strain relief everything and hopefully tidy it up. And they gave us some zip ties, so these should work well together. So I think first, I mean, I honestly could go down here. Maybe I will. Just gonna put one right there. the wire management, I believe, is done. So let me just kind of walk you through what I've done. So we have the lower Z limit switch, wire wrapped that, connected up to the motor and the upper ones, and then that's where I started all the wrapping. Came down in here, I stress relieved it right here, and obviously there's two mounting points there, and then left this here. I stress relieved it in the middle, so that way the cable should hopefully be able to go from end to end. This part is all really messy, but essentially I just bundled it all into one wrap. We have all our limit switches here. The wrap comes down. I do have it tied off here. And then underneath you saw I put a couple tie downs there. So hopefully this is pretty tight here, but the bed shouldn't hit this. And then I just got to be careful to not let anything hit the limit switch, or the emergency stop, that's what it's called. And then I have seen people complain that there's no mount for the power supply, so it just kind of hangs out. I just VHB'd it to the gantry, so hopefully that's okay. It's pretty sturdy on there. I did make sure the fan's on the outside. It was a little tight trying to get these in, so hopefully with everything bunched up it doesn't cause any EMI issues, but I'm liking how it's looking right now. I think it's ready to actually power this up. I will say one thing, it's kind of funny, you can power it up by moving one of the axes. You see that? Alright, so let's plug this in and see if we can get it to move with the manual controller. Okay, so we got the manual controller plugged in. We've got 120 or 115 volts. We did set the power supply to be this voltage, so... Okay, nothing's blown up. Ooh, says waiting. Okay, says 24 volts, 48 volts on, down here on the bottom. 12 volts is good, 5 volts is good. So it looks like we have all the voltages on there. Let's go to control. Okay, so 10% speed. Let's see if we got any of this correct. So, Z minus. Ooh, look at that. Uh-oh. Maybe I held it for too long. Hello? What did I do wrong? I know it hit a limit switch, but that's... Oh, that's spindle 10% speed. So we can do 5, 10, 0.1, 1, 5, 10 steps. I can't get it, so let's power it off. Power it back on. So there's 10 steps, okay? X. So let's try 0.1. 0.1 down on the Z. Cool, 0.1. And then... Awesome. Yeah, okay. So everything seems to be kind of working. That's kind of fun. I was hoping I could somehow get this on here, and then we could run it across the bed and see how everything's doing like that. I don't know if we can, though. See, that's not going to hold it enough. I mean, we could try zip tying something. Okay, so I kind of just am curious how accurate this is. So with even this janky setup, so there we go. That's like almost 10,000. What is that? 6,000 under. Alright, well actually, maybe we're more like, because of my janky setup, we're actually probably more like 4 thousandths difference across here. Well, it goes up a little bit right there. So now let's go, we'll try to zero that a little bit. Oops. So let's go this way. Dang it, so if I hit a stop, yeah, I can't, I gotta like reset it. Dang, okay, so if I hit a stop, then I have to reset the board. So that would make sense why, you know, it would be staying exactly in that direction, just because we're like always, you know, we're always on this point right here. We're never gonna be milling out up over here. We just care about that middle. See, and there's enough flex in there in just these rails that the amount of difference from side to side could just be in the rails itself. So I think that's pretty good. Awesome. All right, well, there we go. And the Z, oh jeez, I don't want 10 steps. Let's do 0.1 step. I would say that's pretty decent. Well, I don't know if this was scientific at all, but it was kind of fun, nonetheless. Let's actually get to doing something with it. Let's clamp something and see if we can't cut something. Probably just do the manual controller right now. Okay, so they did give us 10 engraving bits here, so we're gonna try it out. We're gonna engrave a little bit. Alright, so I had to revise my setup here a little bit. I pulled this off because we're about to hit the limit switch there, and we don't want to do that, but now I can get down into there. So I'm just going to use the manual controller right now and see if we can't make something fun. Again, I've never done anything like this, and I don't have the time to figure out the software, so next time we'll probably do that. But today I want to see if I can do something fun with the offline controller. So, yeah, we just have this little piece of plastic left over here, space it up on some wood. I don't know if it's super flat or anything, but these clamps kind of suck. This is like the height limit of these clamps, and I need to get new clamps. That's something that's really obvious. I mean, they kind of work. I mean, look, they're holding it, but man, they kind of suck at the same time. And I will say I have changed this. They say like put the motor in like halfway, but I spaced it down like this because, again, I want to, at the end of the day, my hope is that it can engrave aluminum amazingly and maybe cut out a bit of aluminum. So I spaced it down here to give it a less of a moment arm. And what will probably happen is I'll be working up a bit more. So most of my stuff will be pretty high off the plate, and then that should work out pretty well. But for today, let's see if we can't make something a little bit fun, shall we? And I did figure out how to get the spindle to move up. If you guys didn't see, you hold OK, and then you go up and down, and you see spindle 50, 10, 1. So at 1%, we can turn it on. I think I'm going to do 50%. Maybe we'll just do 100 and see how the engraving goes. Alright, it's going to get loud here, so bear with me. I guess I should have safety glasses, right? So I will say how I found my Z height is I put this in here, and then I'm at 0.1 steps, and so I just kept going until Oh, see there, it caught it. So that's just above it. So now we're like one step above from actually touching the material. I'll go 5 steps and then kind of move to where I want. And then we'll have at it. All right, going live. Protect your ears. I will do this over here. Here goes nothing. Okay, so this is what we made. It's a little RSP sign. So for the RSP, Ready Set Projects? For the RSP, it was 1/2 millimeter or so in there. And then for the outside, I think it was like 1 millimeter or more on the depth down in there. I will say around the border, I could see the bit deflecting as I cut into it. And I probably should have chose something else because the plastic just kind of bound up inside of there. But, I mean, come on. That's kind of cool. A little RSP sign. Maybe I'll go cut it out on the scroll saw, and that'll be kind of fun. Let's do that. Alright, there we have it. We cut it out. I used a little bit of Sharpie to like darken the engraving we did. I mean, that's pretty good for not doing any G-code or anything. Wanted to get you a little bit of a glamour shot there. I don't know, it's pretty sweet. That is going to be the project for today. We've upgraded. Before we even started, we upgraded it, we took it apart, we put it back together, and finally got it all assembled. It's all put together. It seems to be working just fine. I know we didn't really cut out anything too crazy, but I haven't been into the G-code 3D modeling scene in quite a long time, and I haven't actually done any like CNC machining. So I have a bit of learning to do. In the next project, we will definitely start cutting stuff out. Again, my end goal is engraving some aluminum, cutting out some aluminum, and seeing how it does. I will say I like what I have right here, and I think it's a great starting point. But that's all the time we got for this project, and I'm so glad that you guys came. So hope to see you on the next one, and I should have some links in the description if you want to buy this. I did buy this off Amazon. It was really great shipping and all of that. So if you want to buy this, it would really help us out if you use the links down in the description. Hope to see you guys next time. Hope you guys have a great day, and that's it for today. That's it for now. That's it for... Whew. We'll see you next time. Bye.